Hey guys, hope you guys are doing well this evening. Thank you for watching the video notes. These video notes, I'm going to do them on a separate piece of paper. You're probably going to want to do the same. They go with this claw, which you picked up in class today. Okay, so we're going to talk about parameter changes. So let's look at a common logarithm. So the parent for a common logarithm is going to be y equals log of x. Okay, that's your parent. Remember, it's common because the base is 10. So putting in our parameter changes, we have our a, and then we're going to use parentheses. We have our h, and we have our k. So let's review. Remember that k does what to a function? That's right, it moves it up and down. Very good. And h, that's our our horizontal translation, left and right. And remember, it's always the opposite, correct? Opposite direction. So if it's a +2, it's going left 2. If it's a -2, it's going right 2. And then a, yes, that's right. It's a vertical stretch or compression, depending on what number it is. Okay, so let's look at some examples. So example number 1. And I'm going to go ahead and fill it up with lots and lots of information. Okay, so if you want to pause the video right now and see if you can come up with these transformations, go for it. Okay, excuse me. First of all, there are 4 transformations going on here. First, we have that the function has been moved 1 unit down. So we have a vertical translation of 1 unit down. We have a horizontal translation of 4 units to the, got it, good job, 4 left. So 4 units left. Okay, and then here we have a vertical, good memory, vertical compression. Well done. Vertical compression. Now remember the reason? The reason is because your a value, which is 1/2, don't even look at the negative. The a value is 1/2, and that a value is between 0 and 1. It's between 0 and 1 vertical compression. Okay, and then lastly, what do you think? Correct, we got a reflection. Got a negative on the a value, so we have a reflection over the x-axis. Okay, so next thing I want to talk about is the graph, just a little bit here. So for a logarithmic function, we'll see if I can do this by hand. Probably not, but we'll try. Remember, the point that we move, that we translate, remember that point for quadratic? Remember that point for quadratic that we move? Remember the vertex? Remember we move that left and right and up and down? The point for square root, remember, was that starting point? Remember that? Remember for rational functions, that one was kind of funky because it wasn't really on the graph. It was that point where the horizontal and the vertical asymptotes were that met. Well, for a logarithmic function, the parent goes a little something like this. Okay? Basically. And the point that we're going to move, the nice, neat point that we're going to move, is going to exist right here at 1, 0 on the parent. So this point here is the point that we're going to translate. So if I had the parent graphed and I wanted to graph the child, okay, then I would move it 4 units to the left, so 1, 2, 3, 4, and then I would move it 1 unit down. So that would be my new point. Okay? So next thing I would do is I would notice that I have a reflection, so that this is going to flip. So that means that this portion is going to be under the x-axis, and this portion is going to be above the x-axis. Okay? So it's going to kind of look something, so that's going to go down, and this is going to go up. Okay? Okay, guys. I'm going to go ahead and use Desmos, because when you do it on your calculator, the pixels aren't very good, and it doesn't give you a very clear picture. Now on your iPads, most of the iPads have Desmos app downloaded, so you can use it on your iPads. But here I plugged in the function. Okay, notice that it moved. Here is our point, our special point for our parent. We moved 1, 2, 3, 4 units to the left and 1 unit down. Okay? And notice that it got reflected. It got reflected. Okay? So let's go back here. I'm not really good at I gotta go back to sphere. Hold on. There we go. So on your calculator, it looks like that, and it cuts off the portion that's going up along that vertical asymptote. It cuts it off because the pixels aren't very good. Okay, so it's going to go something like that. Got reflected, translated, etc., etc. Okay. Now when you graph it, you're gonna, if you're using your calculator, you're going to go to your table, and you just want to pick some points that you can easily plot, like -3, -1. That's that point that we translated to. Okay. The points are not very good. Here's one, 6, -1.5. Okay. Keep going, and then none of these other ones would work. But 2 points, that's going to get you a pretty decent graph when you're graphing it. Okay, so now let's take a moment and talk about exponential parent function, or parameter changes. Now we don't have any exponential parameter changes on this worksheet, but I still, hopefully you're taking notes. I still want to show this to you. So let's look at base 10, 10 to the x. Okay, so that's the parent for base 10. So a child is going to look like this. Okay, a times 10, and then x minus h plus k. And there's your parameters for exponential. Parameters mean the same thing. Okay, so if we had something like this, we would say, okay, 3 units down, 7 right, vertical stretch. Okay, let's look at the graph quickly. Okay, exponential is going to look something like this. It's going to go along a horizontal asymptote, and it's going to curve up. Now our special point for translating for an exponential is going to be found at 0, 1. Makes sense, doesn't it? Since logs and exponentials are inverses, their special point is also inverses. 1, 0 for log, 0, 1 for exponential. So if this was the parent for this function, y equals 10 to the x, we would then move it 7 units to the right. So 1, 2, 3, 4, 5, 6, 7 to the right, 3 down. 1, 2, 3. 1, 2, 3. So we'd be right here. And we would probably look something like that. And again, you would plug it into your calculator to get your additional points. Okay, so plugging this into our calculator, we would do 2 parentheses 10 raised to the one of these old operating systems, raised to the x minus 7 minus 3. And there it is. Kind of looks like the one I have. Or you could use Desmos on your iPad as well. Okay. All right. Have a good night. See you tomorrow.